All right, everyone, we are back and we are going to do our fan RPM calculation with our Vernier Photogate. So for this lab, again, we're looking at trying to calculate and take a measurement of basically RPM. I'm going to zoom out a little bit here. We have our good old friend, our power supply. Make sure your power supply, I would just set it at 10. This motor in the fan is actually rated for basically 12 volts, but we're not going to need that much, and actually we really to basically to make the measurements, we're going to run as low as you possibly can, and then obviously ramp up. And there's going to be a limit essentially from the instrument that we can actually measure. So you want this to run as slow as you possibly can make it. So we have our power supply. The power supply, you can see here, we have our positive and negative terminals. They go to our motor driver. So this is our motor driver here. It's described in lab handout. You can see here, I'm going to try to get some good. Our power supply goes directly into that kind of green terminal. So positive and negative, and you can actually see on here, or you will see when you actually wire it, it goes positive and negative here. Now that motor control, then that black terminal you see here, those red and black wires, they go directly, and you can see that they're fed in directly into the fan. So that's how you kind of make the connection here. So you regulate, so you excite, you power essentially the motor, and then the signal essentially eventually will go through there. Now here, and I'm going to zoom in a little bit. Let's see if we can. You see we have DIR, PWM, and our ground. So our ground, unsurprisingly, goes to the ground that is shared with our DAC. So you can see that ground terminal, and it's shared, and it's basically sitting, I know it's a little bit on that kind of row there. So the ground is set up there. So the DAC is connected to our ground here. Additionally, we also, you can see we have our direction also set on the ground. Now, with this particular fan, we actually can't reverse the direction. So we're just going to rotate one direction. It doesn't matter. Actually, or we can't change directions easily, and actually we don't need to. But regardless, we're going to set that to the ground too. So remember, ground from here touches the direction, which is also grounded here. So we're not going to change the direction. Now, PWM is pulse width modulation. That, you can see, is connected directly to our A01. So we're actually going to send essentially some pulse width modulation. We're going to control essentially the voltage. Now here we can only send a 0 to 5 volt signal. And it's weird because kind of this is supposed to be a digital signal, but again, we're going to use pulse width modulation, but it's going to be okay. So that's what we're going to use to control essentially, and we're going to set essentially the voltage which the fan receives. Now here is our photogate. So you can see here right now the photogate is red because one of the fans is triggering it. You can see essentially like the little signal on the side, that's your laser right there. And if I move this, and if you trust me, so you can see still fixed, but let me move the fan. So see, I moved the blade, and now no trigger. So blocked, unblocked, we have 7 essentially fans here, or 7 blades, and we're going to use that to calculate essentially the RPM. Remember, get it as slow as you possibly can. Take those measurements. Right now I'm at like 1.33 volts, and I'm just trying to get it to, it just barely runs and then ramp up just a little bit, so you can get some variability when you're measuring essentially those RPMs. So I'll see you in the next video when we start to, and make sure to save essentially with that corresponding voltage, and then we'll analyze our data. Great, see you then. All right, everyone, we are back, and we're going to do some data analysis now on our good old friend, our RPM lab. So what we're going to do is I'm going to grab all these data files, and actually I'm going to refresh one more time because I thought we had some exactly. Let's make sure we grab everything. So I'm going to grab all these files. There are readouts. So again, I want to make sure, again, try to run it as slow as you, basically you want to ramp from almost 0 and then ramp up slightly, and then you'll kind of see you're going to hit the limit of detection on our apparatus. So what we're going to do, or on our photogate, we're going to do Alt-1. I'm going to say this is going to be photogate, actually no, fan RPM lab. Okay, so what we're going to do is we're going to create a data list, and then I'm going to paste that in here. I'm going to make sure that we're kind of in order, because I want to make it kind of nice and smooth. I want to go from lowest voltage to highest voltage. So 2.9, 330, 3.1, 3.2. Here, let's grab those, because eventually I'm going to plot it. 3.1. All right, 2.9, 3.3, 3.1, 3.2, 3.26. Actually, we have 3.2. This is probably this is the lowest for sure. 3.20. And then we also have 3.28 right here. Actually, no, 3.28 would be highest. I'm just trying to figure out 3.29 for sure, 3.30, 3.31, 3.32. Now 3.26 has to be probably right here, and then 3.28. There we go. Just putting these in order. And then what we're going to do, we're going to go ahead and we'll go ahead and shift enter that. We also should grab, because we know we're going to probably have to do mean CI. Do this. I need the hypothesis protocols. So I want all my data analysis here. Good. And then now we're going to go ahead and do import. Let's take a look. DList1. I'm going to make a voltage list. My VList is just going to be equal to 1.32, 1.326, 1.328, 1.329, 1.330, 1.331, 1.332, and 1.325. There we go. So I don't really care about time. I wish we would have had more measurements, and we could actually probably tune that later. But it's good to it's kind of an average and an average anyway. So I want all 2, and I want from 2 to -1. There we go. So now I can go ahead and just set this up like so. I can do J, comma, J goes from 1 to length of DList. So that gives me all of my data. So I have the RPM dat, like so. So these are my RPM measurements. I can go ahead now and just basically say, for example, I can say build a function where it's VList1, so my corresponding voltage, and then I want around, and I'm going to take the mean of RPM dat 1, and then I want basically this minus mean CI of RPM dat 1, just like we did previously, 1. And then close it, and then show it here. This is boring because there's just 0, 0, zeros. And now we can say I loop it. I, then we can go I from 1 to length of my DList. And there we go. And we can go ahead. So I'm going to say my P plot, because this is only precision error. So I'm going to say list plot, PP plot. And we can kind of see. Now, one thing I'm a little bit, what's happening? I don't think it likes. It's not liking one data point. 1.32. Let me see here. It doesn't like the. Oh, there's another. So 1.325 should be. Wait a second. I may have made a mistake here. Yes. 325 should be over here. Copy paste. It's okay. 1.325. Shouldn't matter, but it actually does. It doesn't matter, but I don't like the. Now, in terms of the aesthetics of the plot, what it doesn't like is the fact that basically there's no around here. It's just 0 because there's no standard air and all those types of things. But you can kind of see here which are statistically significant, which are not, which air bars overlap. But remember, this doesn't include the bias air, and I'm expecting you to include the bias air, and I hope you can figure out that calculation. So that is our RPM. We're measuring essentially RPM of a fan with our Photogate. It's fantastic. And you can see, I mean, at some point, there's a big statistical distinction as we kind of run lower and slower and faster. And as we kind of anticipate as you increase voltage, it increases. So fantastic. So we'll see you in the next video. Thanks. Bye.